Let's take a look at visualizing the workpiece. To familiarize you with the CNC turning center, traditionally the chuck is located at the left end with the workpiece towards the center and the turning tools coming from the upper right-hand corner. This would be a conventional two-axis CNC turning center layout. In future simulations, we won't be showing you all of the details shown below. We will be showing you only the upper half of the workpiece, otherwise known as a radius view. The tool will still come from the upper right-hand corner just as it would on a conventional turning center. Now let's learn about the axes of motion. The z-axis on a CNC turning center is a motion that is parallel to the center line of the spindle. Notice the red line representing the spindle center line near the bottom edge of the part. The z-axis motion would be a left to right motion on a conventional CNC turning center. The x-axis of motion moves perpendicular to the center line of the spindle. That would be an up and down motion of the tool. Between the z-axis and the x-axis, there is a perfect 90-degree angle between these two. Let's take a look at some of the basic machining operations that can be performed on a CNC turning center. Turning operations are machining operations that are performed primarily on the outside of the workpiece, and the motion is primarily moving along the z-axis. This is what truly differentiates a turning motion from a facing motion. In this example, we are only demonstrating a straight turning cut. With rough turning, you will have to take several passes to remove all of the material from the diameter of the workpiece. This would be considered a rough turning operation. Rough turning operations are made up of many different movements. To simplify the programming of these operations, there are special cycles that can do this automatically for you. We will be learning about those much later on, though. A finish turning operation is one that removes a small amount of material from the outside diameter of the workpiece. Typically, we would only be removing 40 to 60 thousandths per side on the workpiece. Because it is a finish turning operation, the feed rate would be kept relatively slow so that our finish would be very nice. Notice also that even though this is a combination movement of x and z-axis motions, it is primarily performed along the z-axis. Facing cuts are cutting motions that move primarily along the x-axis, and in most cases the facing cut will start from the larger diameter moving towards the center line of the workpiece. Rough facing operations take a series of cutting motions going from the large diameter towards the center line of the workpiece, stepping over on z-axis for each cut. As with the rough turning operation, there is a cycle that will automatically rough face a workpiece for you. A finish facing cut would take a small amount of material off of the front of the workpiece. Typically this would be about 40 to 60 thousandths of an inch. Notice also that this motion is comprised of different movements between the X and Z axes, but the primary direction of cut is the X-axis motion, and it is moving towards the center line of the workpiece. Drills can be used on a CNC turning center as well. We would consider this a drilling operation. The tool would have to be moved down to the center line of the spindle, which would be considered X0. The tool would then be fed into the workpiece along the Z-axis until the depth of the hole is reached. A peck drilling operation would be very similar to a regular drilling operation, except that the tool will feed in a given distance, retract out of the hole, wrap it back into the hole, and feed another given distance. This process would repeat itself until the final depth of the hole had been reached, at which point the tool should be retracted out of the hole. A boring operation is performed on the inside of a workpiece. A pre-machined hole must already exist in the workpiece. The primary direction of cut is along the Z-axis. A rough boring operation would take a series of passes from the small diameter of the bore, working out larger and larger in diameter to remove most of the material. Just with facing and with the rough turning, there is an automatic cycle to remove the bulk of the material for you. A finish boring operation removes a small amount of material from the inside diameter of the workpiece. Typically this is in the range of 40 to 60 thousandths of an inch. Notice also that it is primarily a Z-axis motion, but in the case of finish boring, you will see that it is a combination movement of both Z and X axes. In this example, we are demonstrating an OD grooving operation. Grooving is unique in that the finishing and the roughing are performed with the same tool. First, you would bring the tool over to the center of the groove, plunging down on X-axis to remove the center portion of the groove. Then, moving the tool to either side of the groove, you would feed down, forming the side shape of the groove, repeating that process on the other side of the groove. Single point threading is very common on CNC turning centers. Here we are using a single point tool and taking a series of passes across the diameter of the workpiece. A special feature on the machine allows the tool to start at exactly the same rotational position every time. This way we can take very light passes each time, removing the material gradually so that we do not break the tool. Absolute and incremental coordinates are our next subject. CNC machines have two types of coordinate systems, absolute and incremental. With absolute coordinates, we use the letters X and Z to represent the axes. With incremental coordinate system, we use the letters U and W to represent the axes names. The U would be used for the X-axis. W would be used for the Z-axis. Although absolute is used almost exclusively nowadays in programming, it is important for you to understand the difference between incremental and absolute programming. So we will first focus on incremental programming. Then we will move on to absolute programming. Incremental coordinates are used to tell the tool how far and in which direction to move. We would specify the direction by using the letters U or W. For example, if I wanted the tool to move to the left along the Z-axis, a distance of 1 inch, I would command simply W minus 1.0. If I wanted the tool to move to the right a half of an inch, I would command W 0.5, and the tool would move to the right along the z-axis 0.5 inches. The x-axis, regardless of absolute or incremental, is always programmed in diameter. Therefore, if we were to program a command U minus 1.0, the tool would move 1 inch smaller in diameter. In this demonstration, we will be explaining how to program a finish turning operation using incremental coordinates. During the lecture, you can press the green button at the bottom of the screen to run the animation. You can run the animation as many times as you would like. Here is that same program example again. This time I've put the commands also down by the workpiece so that you can see how each command within the program relates to the workpiece. It is very important to understand that with incremental coordinates, we are always telling the tool which direction, using U or W, and either a positive or a negative value, and how far to move, specifying that with a numeric value next to the letter. As in this example, our first command, W minus 0.4, means that the tool will move 400 thousandths in the left direction, or Z minus direction in this case. Here we are at the incremental coordinates game. The objective of this game is to program the tool to move along the part as if it were finished turning the part. You will choose from the commands located at the left of the screen. To select a command, click on the green button next to it. Be sure to select the commands in the proper order, otherwise your tool may wander off into an unknown direction. If your tool gets lost, it's very easy to restart the game by clicking the red button located next to the text that reads Reset to Start. Do this game several times so that you get the hang of incremental coordinates. When you are finished, click the Next Page button to continue on with this lesson. If you finally got it correct on the last screen, this is the order in which the commands would be executed to finish turn this workpiece. Take a good look at it because this is probably the last time we'll be reviewing incremental coordinates. Again, it is important that you just understand the difference between absolute and incremental coordinates, as absolute coordinates will be the preferred method of programming. When we are programming with absolute coordinates, we are never telling the tool how far to move or in which direction to move. Rather, we are telling the tool what position to move to. For example, if we were to tell the tool to move to x 0.5, we would be telling the tool to move to a ½ diameter. If we were to tell the tool to move to z minus 1.0, we would be telling the tool to move to a position along the z-axis 1 inch to the left of program 0. Program 0 is a specific position on the workpiece that we assign as a programmer. Program 0 is a position that we can assign anywhere on the workpiece. But you will find that most programmers will assign program 0 at the center line of the workpiece and at the rightmost finish face on the part. This has become pretty much the de facto standard with all CNC programmers. There are times when assigning program 0 on the left finish face is acceptable. This is usually the case in bar feed operations. But even in shops that do a lot of bar feeding, oftentimes they prefer to have Z0 on the right finish face of the workpiece. Throughout this course, we will be assuming program 0 to be at the rightmost finish face and at the spindle center line. On this slide, you should be able to truly see the difference between absolute programming and incremental programming. On the left side, we are showing you a workpiece that is dimensioned incrementally. Notice that each dimension goes from one position to the next. From the front of the part going towards the back, we have a 400 thousandths dimension. Then we have another 400 thousandths dimension. And then the last dimension is 200 thousandths of an inch. This would be very, very similar to incremental programming. On the right side of the screen, you will see that all of our dimensions along the z-axis are coming from the right finish face, program 0. In this example, you will see that each dimension coming from there goes towards the left. So our first dimension, 400 thousandths, to get to that position with absolute coordinates, we would command z minus 0.4. The next step is an 800 thousandths dimension. To get to that position along the z-axis, we would simply command z minus 0.8. And finally, the last dimension along the z-axis is a 1 inch dimension. To get to that position, we would command z minus 1.0. Any position to the left of program 0 would be considered a z minus position. Any position to the right of z0 would be considered a z positive position. Follow along now as we go through a program example using absolute coordinates. If you would like to run the animation at any time, just click on the green button located at the bottom of the screen. Here we will move the tool to a diameter of x 0.5 and a position on the z-axis at z0. That would place the tool right at the rightmost finish face and at a diameter of x 1/2 inch. Our next command, x 0.5 z minus 0.4, places the tool 400 thousandths to the left of the finish face at a diameter of 1/2 inch. The next command, x.7, z minus 0.4 places the tool at a diameter of 700 thousandths and at a position of z minus 400 thousandths. 400 thousandths to the left of the finished face. The next command keeps it at a 700 thousandths diameter, but moves the tool to the left to a position of 800 thousandths to the left of the finished face. The next command moves the tool up to a diameter of 800 thousandths, but keeps the tool at a position of 800 thousandths to the left of the finished face. The next command, x 1.2, z minus 1.0, is a combination movement. Notice that the values for x and z both change. This tells me that the tool will be moving at an angle. We will end up at a diameter of 1.2 inches and a z position of 1 inch to the left of the finished face. The last command, x 1.75, z 2.0, moves the tool away from the part to a convenient tool change position. We will be explaining tool changes in the next chapter. Again, try to run this animation several times and follow along with the program so that you understand absolute coordinates. If you're still a little bit unsure of absolute coordinates, take this program step by step. The commands are in proper order to finish turn this workpiece. If you click on each button, it will put the tool at that X and Z position. This is a good way to visualize absolute coordinates. Go through this as many times as necessary until you are sure you understand absolute positioning. Just keep in mind that with absolute programming, we are always moving the tool to a position that is relative to program 0. On this screen, we have another game for you to play, the absolute coordinates game. We have gone through and written all the commands for you, but we've just mixed the order up in which they occur. What we want you to do is, by clicking on the green button next to the commands, move the tool in the proper order to finish turn this workpiece. If you get all messed up, just click the red reset button and that will place the tool back at the beginning. And then you can go through and select the proper order to finish turn this workpiece. Do this several times until you get the hang of it. It's quiz time! You will have to answer 10 questions during this quiz. On some of the questions, you will first be presented with an animation. Study the animation carefully and try to picture what we are explaining to you. When you think you understand what you see, click on the green button. That will bring to you the question. Each of the questions within this quiz are a multiple choice question. Read all of the answers and click on the button that you think is the correct answer. Your score will be presented at the end of the test. When you think you know which axes of motion we are demonstrating, click the green button. If you think you can tell me which axis of motion this is, click the green button. For purposes of simulation and animation, as well as programming, which one of these views would be correct for visualizing the workpiece? When you think you know what type of machining operation this is, click the green button. Are these absolute commands or incremental commands? Which machining operation could this be? When you think you know, click the green button. Our primary axis of motion is the z-axis, and we're on the outside of the workpiece, so that must mean we're performing what type of machining operation? Click the green button when you think you know. This is a toughie. Look it over real careful before making your selection. Let me see. We used program 0 for incremental coordinates or absolute coordinates? Don't give up now. This is the last question. You made it. Now take a moment to go through an evaluation to see what your next course of action should be. If you scored 0 to 50%, you should review the entire lesson. If you scored 60 to 80%, review the trouble areas where you had the most difficulty understanding. If you scored 90 to 100%, great job. Continue on to the next lesson. But before you do anything, what we need you to do is to enter your name. Take the mouse pointer and move it into the box next to student name. Click the left mouse button once, then type your name. After you have your name entered, a button will pop up at the bottom of the screen that says Print Quiz Score.